Okay. Welcome everyone. We're going to get started now, and people are still joining a little bit, but they can catch up at this point. So, I want to thank you all for spending a little bit of time with us. I'm joined here today by Tim Ebers, who is our field CTO, and I'm Tim Erlin, VP of Product, and we're going to talk about adding API security to your Mulesoft environment. Before I get started, just a little bit of housekeeping. We are recording the session, and we will be happily sharing slides with people who are interested in them. We're also broadcasting simultaneously on Zoom and on LinkedIn, so you might be attending through either one of those mediums. They're both great. We do have a couple of poll questions in here, and the poll questions will be answerable on Zoom, although we'll ask people to toss their answer into the comments on LinkedIn as well. And then I'll look at the results from Zoom and share them as we go. Also, if you have questions for Tim or I as we go through this session, feel free to add them to either the Q&A section in Zoom or add them as a comment in LinkedIn. And we'll do our best to answer them where we have time. And if we can't answer them, we'll try and get back to them after the session as well. So I think that's all the housekeeping items, and I think we can officially get started here. So I'm going to start by putting up a big number right in the middle of the screen, 70%. That is the number of application attacks that are now targeting APIs. And let me explain a little bit about where this number comes from, because one of the things that WallArm does with our platform is we track information like, what are attacks targeting, what types of attacks do we see, that kind of thing. And what we've seen is a shift in the number of attacks that are targeting APIs versus web applications. And that number in 2023 was 70%. So better than a majority, let's call it the vast majority of attacks that we now see coming across our platform are pointed at APIs and not at web applications. And that's a shift that's occurred over the last couple of years. And that's part of why we're here talking about API security and talking about Mulesoft. But let's put a little bit more detail in that. There are a number of reasons that attackers are specifically targeting APIs or are shifting from web applications to APIs. And I think, Tim Ebers, I'd love to have you jump in here and talk a little bit about, why you see APIs as fundamentally different from web applications in terms of an attack target. We've got some of the reasons listed up here, but what are your favorites?
Yeah, I think for me, from my background, APIs are just so much easier to attack. Why? Why are they easier to attack? Because we're giving well-structured data out to the bad guys. So we've moved the data from being embedded into HTML, embedded into JavaScript, and really making it more difficult and a little bit harder to deal with. We've now moved that paradigm and said, hey, let's take the database, put an application in front of it. And sometimes people are just using the database, putting that on the edge, and really driving structured data, which is really what we're trying to protect here. It's not actually the APIs. They're targeting the APIs, but why? It's the data inside the APIs that are really important. And we just moved that as close as we could to the attackers without actually just giving them access to the data. So it makes it so much harder. And the reasons why APIs are so much more valuable intrinsically valuable to the bad actors.
Well, it's really two sides of the same coin. The purpose of an API is to support programmatic interaction, to present data in a well-formatted way, to make it easier to build integrations between products. But all of those attributes that make APIs favorable for building and deploying applications also make them favorable as attack targets. Because why should I spend time writing writing code to scrape HTML or a form or any of the other web technologies that were popular up until recently, when the API will hand me the data I'm looking for in a nice, XML or JSON format, right?
Right. Easy to parse, easy to see if you got anything back. Yes, relatively easy to use, and which is why it's being used and all over the place.
Yeah, and that all of those attributes make APIs popular targets for attack. So I did say that we'd have a couple of polls. I'll start with the first poll question here. So if you're in Zoom, you'll see the poll question pop up, and you can answer it. I'd love to have your answer in there. And if you're on LinkedIn, feel free to toss your answer to this poll question into the comments. Maybe start a conversation there with that. But really, we're interested in what you're seeing as sort of the attack attempts targeted at your organization. Are they still traditional web apps, still APIs, about equal? not sure. So if you pop your answer in there, I'll give it just a second, and then I'll ask for the results when my assistant determines there are sufficient results. Will you pop them up there, Brandon? If we get some results,
I,
if
I
anybody
just
answered
don't
it.
I don't understand why we can't vote. Like I never understood why for
Oh, why the
polls and
presenters can't
quizzes,
vote?
why can't we vote?
I know. It's true. Okay, there we go. So we've got some answers. Mostly APIs, about equal. Not sure is always a fair answer. So what we're seeing for the folks who are on LinkedIn is that 50% said mostly APIs, 17% said about equal, and 33% said not sure. So 0% said mostly traditional web apps. Now, we should keep in mind that there's a certain amount of self-selection going on for people who are attending a webinar about API security, but still, it matches up with what we're seeing in the actual attacks. So I do want to talk a little bit about I'm a big fan of patterns actually. And so I want to talk a little bit about this pattern that we see in the adoption of technologies by attackers and the defensive technologies that go along with them. Uh, this is a pattern that's currently playing out with APIs and API security, but it's one that exists beyond that, where the security posture or the defensive technologies lag behind those new attacks. So if you think about this line on the screen now as the attack adoption curve, when a technology is newer, when it's less distributed or less popular, you're going to see, fairly sophisticated attackers targeting it. We've labeled them as state-sponsored attacks, but I think sophisticated attackers is probably a good, a good thought there. Early adopters on the attack curve, if you will. Um, Once that technology is distributed wide enough for people to make money, then you see cyber criminals moving into that space because there's an opportunity there for them to make money. And then as the time passes and the adoption of the technology expands, that's where you see widespread automated attacks. And what we're seeing, if we plot that 70% on the line, this is where we see ourselves in 2023 as of last year, where 70% of the attacks were targeting APIs, not web applications. So we're hitting that curve of widespread adoption of attacks. And if we just go back to 2022 and look at what that split looked like in 2022, so what percentage of attacks targeted web applications, APIs versus web applications? In 2022, 54% of the attacks were targeting APIs. So even in 2022, we were still at a majority of the attacks targeting APIs versus web applications, but it jumped up to 70% in 2023. So a fairly rapid increase. And we expect that that's going to increase again in 2024. We're continuing to compile our threat stats data to produce our reports, but we haven't finished out Q1 yet. And so we're expecting that to continue going up, but we don't know what that number is yet. So now if we layer alongside that the curve for defensive technologies, in this case, the adoption of API security and the capabilities around API security, you could see that, sort of in that space this year, I would say, 2023, 2024, we're looking at the adoption of API security as a practice, as a tool set by, sort of banks and, regulated industries, federal government, organizations that might be a little slower to move, but tend to put in place really strong programmatic applications for their security controls. We're not at the point of widespread adoption yet of of API security as a tool. And what does that mean? Well, it means that we have this gap between this period of time where we have widespread automated attacks that are either coming or nearly coming, but we don't yet have widespread adoption of the tools. This creates a gap that's really high risk for organizations using APIs. In this case, that's the technology we're talking about. It also creates a gap that, if you were to flip this and take the attacker's perspective, would be considered the high opportunity gap, where the attackers have a great chance of using a wide variety of tools and capabilities for attacking APIs, but finding relatively few defensive capabilities deployed in those organizations they're attacking. And that's where we see ourselves today. And that's why this conversation is so important about API security. But this conversation, this particular webinar, isn't about just API security. We specifically wanted to talk about API security in Mulesoft environments. So, I mean, Tim, when you look at an organization and you see that they've deployed Mulesoft, as an API gateway for API management, what does that tell you about that organization?
That they like Java. No, actually, MuleSoft's actually coming out with some Rust-based gateways as well, which I'm excited to see and play with. Really, when you've delved into MuleSoft, what you're trying to do is orchestrate data in between APIs, right? So MuleSoft is much more than just an API gateway. API gateways are great, and they do great things when you're trying to manage and maintain the APIs behind them. MuleSoft is a much different animal and allows you to do so much more than just managing the APIs. And so when you start looking at orchestration of data between APIs and actually creating different data on the way out, your APIs are just more sophisticated and complex. And I like the word sophisticated because you can have really simple APIs that you're then orchestrating together. So that's not necessarily complexity, but it's a bit of sophistication, taking data from this API, taking data from that API. And so by its very nature, you have higher call volumes to be able to drive those different requests and pulling data out of different APIs from across the organization. We see a lot of, I'm taking HR data and pulling data out of an HR system and then sending them to maybe Active Directory for onboarding. So there's lots of ways that people use MuleSoft in order to make jobs easier. And that's really the point, is getting the data to the right place at the right time.
Yeah, yeah, yeah. And I think you hit almost all of the points that we put on the slide here. More sophistication and complexity, higher call volumes. To me, all of that stems from, greater business value. An organization that deploys MuleSoft as a tool is really leveraging those APIs in business critical fashion, right? They're part of their business, and that means that there's greater business value involved there as well. Of course, that's the perspective from, sort of an operator or a business side. There's also an attacker's perspective here as well. So if you're a MuleSoft customer, the attacker sees that sophistication and complexity as the potential for more mistakes to exploit, more opportunity to exploit. Higher call volumes can mean that it's easier to evade detection because it's harder to see their attack within that volume. And of course, the business value, if you're a MuleSoft customer, your APIs are valuable. That means they're valuable to attackers too. There's something there worth stealing. So that perspective of the attacker is important. Deploying MuleSoft has great business value, lets you do a lot of things around those APIs that are important, but it also makes you an attractive target for attackers targeting APIs. And that really brings us to the question of what you should do, which is always the most important question, right? We talk about what the environment looks like, what the threats are, but what should you be doing about it? Well, I'll start with the fact that MuleSoft offers their own API security best practices, and they sort of ask two simple questions there. If someone were abusing your APIs, would you know? And how can you find vulnerabilities throughout the life cycle? So there's nothing wrong with looking to MuleSoft as for some guidance around what you should be doing to secure those APIs. But MuleSoft isn't the only organization out there providing guidance. There are a bunch of them. You've got OWASP, who produces their API top 10. You've got analyst firms like Forrester and Gartner that also produce guidance around API security. And then, of course, you got vendors like WallArm and our research around what we call API threat stats and what those threats look like, which is a little bit less guidance and more assessment of the threat environment, but there's certainly guidance in there. So we wanted to actually take these 5 organizations and really analyze, catalog, classify, analyze the controls and actions that they recommend that you take, and then put them together and see what the commonality looks like, or what the common results are. And the original version of this presentation included all of the details for each of these. And as we went through it, we decided that was too long for a presentation. So for the recorded presentation, we're going to include all of that detail, the list of the OWASP API top 10, the list of what MuleSoft recommends as the top 5, et cetera, et cetera. But for the actual presentation, we're going to skip the detail and get to the conclusions. That's the idea here. So when we combined the controls recommended by these different organizations, we categorized them and then we subcategorized them, and we produced a little bit of analysis here. So this is the combined best practice frequency based on the categories that we selected. So when we broke this down, what we saw was that the majority of these organizations are recommending heavily around secure design and threat protection. So those are kind of the two pillars that had the most recommendations. API discovery was next, bot protection after that, and then secure testing had the fewest recommendations based on our categorization. So that's what the summary results looked like. But we also took that down to some subcategories. So within those top level categories, these are the subcategories of the actual controls that they recommend. So just to give an example and put some color around that, there's a subcategory for denial of service attacks. It's categorized under bot protection. Within that subcategory, there's a specific recommendation for deploying and applying rate limiting, as an example. So just to give you a sense of what the structure looks like. So this is that summary of best practices, and as I said, we'll include the detail for each of the organizations in the slides if you want to request the slides themselves. And then what we did after this was we took a look at what Mulesoft provides as a whole and found that Mulesoft provides a really solid foundation in a number of ways, but there are also a number of gaps where if you've deployed only Mulesoft, you're not really getting all of the capabilities that you need around API security. So, for example, I like API discovery as an example. MuleSoft can help you document the APIs you have, but they don't really do API discovery. If you want an API discovered by MuleSoft, you essentially have to find it yourself first and then have MuleSoft discover it. It's not really designed to do that. Also, MuleSoft supports a very basic web application firewall that uses the mod set core rule set. So it can do some basic attack detection, but it's really missing a lot of the capabilities that you want for protecting APIs from API centric attacks. And in fact, if we were to spend more time diving into this, the green check marks should probably be some kind of percentage or a score. But the goal here was really to say, I think MuleSoft provides a solid foundation, but there's some things missing that we still need to talk about. And if we're going to talk about what's missing, we thought it would make the most sense to talk about it in terms of a maturity model, because not every organization is the same. And in order for you to decide what you should be doing and prioritize the actions, it's best to actually have some kind of a maturity model against which to compare your organization. So this is the maturity model that we put together that we wanted to share. You've got 4 basic categories, and then we kind of split it into developer driven and security driven. So if you think about this, initially when you're first developing and deploying APIs, that's really a developer driven process. You're going to focus on, from a security perspective, you're going to focus on things like secure design, making sure that you've actually built the right authentication authorization into the APIs themselves. This is where a lot of the OWASP API top 10 actually applies. A lot of what the OWASP API top 10 recommends is that the developers go fix something. So you're going to want to make sure you manage your credentials, and you might spend some time doing API discovery, but it's likely to be more around creating a catalog of the APIs you have, rather than actually performing objective discovery of the APIs you've deployed. But those are all good things to do at that first step. As those numbers of APIs grow in your environment, you're going to expand what you're focused on, but you're still likely to be more developer driven than security driven. So, you can expand the subcategories of secure design that you look at. Growing number of APIs generally means that you've got growing usage. So things like denial of service attacks become more important. Things like managing sort of governance of APIs deployed against specifications. So shadow APIs, great example there. Do you have APIs deployed in your environment that don't match your specification? That second step is often where you might start doing more regular security testing against those APIs. And then this is where we think threat protection tends to show up. Some threat protection at least. So you start looking at capabilities to protect yourself from basic attacks that might be coming across targeting those APIs. And then somewhere in this space, there's a shift from that developer-driven to more of a security-driven approach to API security in this maturity model. And again, secure design continues to evolve. But you start doing more things around API discovery, because at this point you've got so many APIs deployed in different ways that it's hard to actually manage them without a discovery tool to collect all of that data and help document them. You might have improved security testing as well, but then the threat protection really becomes a focus, because at this point, organizations, when they pull in a security-driven approach, security starts asking more questions, starts exploring the threat environment, starts looking at API-specific tools, more behavior-based protection. And actually, Tim Ebers, I think you've got a great explanation about the difference between sort of stateful attack detection and stateless attack detection, and what that means, for different types of attacks. Can you explain that a little bit?
Sure. When I talk to customers about the different attacks that we're seeing with APIs, the two different types that I look at are stateful and stateless. So what does that mean? So a stateless attack is where the request has the attack in it. Those are your injection attacks, your XSSs, your RCEs, your PTRAVs, and the like. So those are stateful. I don't care about what was before it. I don't care about what's after it. That request has the attack in it, and so I call those stateless. Right? I don't need to know anything about the state, the sessions, the IPs, where they're all coming from. That thing has an attack, and I'm killing it. And then the stateful side of this is all your behavioral analysis, your BOFLAs, your BOLAs, your IDORs, your bad business logic flows. Those are all stateful, right? One request isn't going to show you if it's good or bad. You have to have a group of those requests. So then you're analyzing those groups of requests to see if those anomalous requests are in totality a bad clickstream, as I call them.
Mm-hmm.
And then
it's not that one of those attack types is more important to detect than the other. It's that they're different detection mechanisms, different detection requirements.
Yeah, they're different. They're very, very different. The mechanisms that we use to identify them are very different. And so thus, when you're looking at your maturity model, as your numbers of APIs grow, and they grow across teams, is really where security and risk and governance really come in, so that they can drive the data and understand who's using what data and for what. So if you have data in an API that nobody's using, why do you have that data there? Why do you allow it to be requested there? And I think those are the types of things that I don't know that, when I've worked with application developers, they get told to create a thing, and they go create that thing, and then they walk away, unless somebody tells them to go back and change that thing. Where security needs to come in at that same time and watch what's going on with that API to see if that data is actually being used. And if not, maybe that data needs to be pulled out of there. And I think that's, as you grow your maturity of the particular environment, the more governance, and I'm not a big fan of the governance word, the more eyes on who's using what data, the better off you are. And that's really what this maturity model is trying to help understand. And it's, the nice thing is you can take the little bullets out and change them and move them around where you think they're right. But, here what we're trying to do is show you that you need to start with, the developers are going to develop a bunch of stuff. You need to be sitting alongside them. You need to be watching what they're doing and helping them implement it as securely as possible. And then come alongside them after they're done with that API and watch it with them, so that you and they know what's happening and who's seeing what and what's happening.
Yeah. So Brandon, I'm going to ask you to pop up the next poll question while I talk about the last shift in that maturity model, because Tim, you brought up that you don't like the term governance, and I was almost about to say that I really like the term governance, especially to describe that last step in the maturity model, because you can get a really long ways down the path of protecting APIs, with essentially that security driven, approach. But when you have multiple teams that are connected to the business in different ways, at some point you have to start applying the principles of governance, which I think you still describe, even if you don't like the word, to the model overall, and start doing things like having an overall body or some oversight over how the data is being used in the myriad of APIs that you're building and deploying as well.
Yeah, and the reason why I don't like the term governance, because it assumes somebody has the ultimate authority to say yes or no. I like the term more co-oping, right? You're co-oping security with the developers, you're co-oping it with risk, and together you guys are
Yeah.
creating the best that you can in what you have before. Governments to me, when I've been in operations, has always been something that was difficult and hard to get through, um, because it's there isn't something set in stone that says this is the way you need to do security. That's not how security works. And that's why security by layers came about, and which is why I don't like the term governance, because there isn't a right way. It doesn't exist in security. There are
Yeah.
lots of
Yeah.
different ways. And so the term governance to me means that there's ultimate authority for that. And I just don't think there is. There's so many different ways to go after these things it's just, I like co-oping, right? We're co-oping security together because security can't do it alone. The developers probably need some help. Risk can't
Yeah.
do it alone. So that's why I like co-oping.
It's a good way to look at it. To me, governance is about perspective, right? Those developers and even security, they don't necessarily have the full perspective, and so someone has to be able to bring that perspective and share it in a way that allows them to make the best decisions possible. So uh, yeah, that's great. So I did see the answers for the poll question pop up for a second there. I don't
Where'd
know
they
if we can,
go?
yeah, can we get them back for
There
a
they
second?
go.
Great, perfect. So for those of you who are watching on LinkedIn, what we've got here is nobody on this call said that they're developing their first APIs. That meets the self-selection criteria for attending the webinar. And then we had 25% at growing API volume, 50% in the mature API environment, and 25% said they're at that high security environment, that top of the maturity curve. And that's interesting. That's maybe
That's a
a
really nice
distribution
bell
I didn't
curve.
expect.
I
It's a
did
good
not
bell
me
curve.
either, but it is a good distribution.
Yeah, yeah.
Now, maybe not statistically significant based on the numbers.
Well, that's always a question with we don't design the webinar polls to be statistically valid necessarily, but it's
Oh,
always
come
good to
on.
get the interaction, a little bit of feedback along the way. So let's move forward and talk about three ways to close the security gaps that we've been talking about so far. I always like to include a couple of different options here, but let's start with start with what you have. You've got existing tools, and if you're looking to close these gaps, there's no reason you shouldn't start by looking at those tools and what their capabilities might be. Might give you an opportunity to do something with the tool you already own. So there are a couple options here. There may be other tools that are relevant, but a web application firewall, is a good place to look. Keep in mind that generally speaking, a traditional WAF is going to have minimal API protocol support. It might not decode the whole request, which can limit what kinds of attacks you would detect. Often WAFs are really deployed only at the edge, so there's limited visibility there. And so, the conclusion of that is, although the WAF you have might have some API capabilities, it might just miss attacks. But it's better than nothing if that's what you have in place. You can also look to your existing AppSec scanning tools, a DAST or a SAS tool, and they can provide certainly vulnerability detection in APIs to varying degrees depending on which tools you're looking at. But keep in mind that they're not providing that real-time protection. They're scanning tools, so they're not looking at traffic. They're not detecting and blocking attacks. They're not generally doing API discovery. So in most cases with these types of scanning tools, you have to provide them with a specification as a starting point for doing that vulnerability scanning. And that's because unlike web applications, you can't really crawl an API. It doesn't have links you can follow. There's no start page that you can then spider from. That's why you have to start with a specification. And that's also why API discovery is so important as a capability, because it gives you that information about what you actually need to test in your environment. Of course, API gateways, we've talked about how Mulesoft is a solid foundation and can provide a lot of value. When you look at API security, we looked already at what might be missing. The API gateway generally is good at providing authentication and authorization functionalities. It's generally not going to be the tool that does a great job at detecting and blocking attacks, especially more sophisticated attacks. Also, that API gateway generally isn't going to provide API discovery or testing. So it's going to take the APIs you already know about, provide valuable foundational capabilities there for managing those APIs, but it's not necessarily going to extend into some of the API security capabilities we talked about. And then last but not least, you might look to secret scanning tools to help you identify sensitive data in your code or in your APIs. Um, Great tools, but they are only limited to finding secrets in your code, not secrets that have already leaked out into the world, sensitive data. And they're also limited to what they categorize as secrets, not necessarily to all sensitive data that's related to APIs. So if one of your concerns is about leaked data outside your organization, that's a tool that you might already own that could be helpful, but doesn't necessarily cover everything. Of course, existing tools are one option. Another option is to look towards open source capabilities, whether they're libraries or tools. There are lots of open source options out there that can help you improve your existing API security capabilities. Mod security, popular firewall, certainly has limitations, but is out there. API firewall is actually a wall arm open source tool that focuses on APIs. And we recently added support for mod security rule sets to API firewall. So if you're interested in an open source option for an API firewall that supports mod security, API firewall is good to check out. There are open source gateways as well. I would point out that given the subject of this call, there's a good chance that the vast majority of participants already have an API gateway in place. But those open source gateways have their place in the market as well. There are some open source API discovery tools like API Clarity, and then one of my favorites is that you can never go wrong with log analysis. There's so much information in logs, and if you can produce good
Mhm.
logs and analyze them, you can do a lot with a relatively small tool set. I don't know, Tim, you sounded like you made a noise there.
Yeah, for those that know me, back when I was at Victoria's Secret, we would literally dig through terabytes of logs a day. We had a big MapReduce environment where we would mine all of our log analysis. And unlike most logs, what we actually ended up doing is, for the most part, logging all requests and responses, because that's where actually the good data is. And the problem and where these log analyses fall down is I can't see the request, I can't see the response unless you're specifically um, uh, logging that, which most people don't do, which is why I made it's easy to say, it's really hard to do in practice.
Yeah, yeah, yeah. And I think the limitations that you see in the existing tool sets and the open source tools that are available, they're what have led to a market for what you could call API first security vendors like Wallarm, right? So tools that are specifically focused on API security, and there's certainly set of core features to look for there within those tools. API discovery, threat protection, testing, integrations, et cetera, are that core set of tools or core set of capabilities rather. And then there are some things that we think are particularly important to pay attention to when you're selecting an API security tool. First of all, you want to make sure that that tool can actually perform inline attack detection and blocking. Like, what's the point of detecting attacks that you can't block in real time? Obviously, support for the protocols that you care about is important. So if you're building and deploying APIs, you've got to buy a tool that supports the protocols you're using, um, and making sure that those tools can actually parse the entire request and decode those requests if they're encoded. That's important for capturing attacks. We also see passive vulnerability assessment as an important capability. So vulnerability scanning is useful, but if you're analyzing all the traffic, there are vulnerabilities that can be detected either through that traffic analysis or maybe only through that traffic analysis as well. Rate limiting is one of the core capabilities that's mentioned in the security controls we were talking about. Making sure that that rate limiting works specifically for APIs is important as well. We also think that API leak detection is a key capability. You may have seen about a month and a half ago, Mercedes-Benz had an incident where the API token for their GitHub repository was published on a public GitHub repository. So if someone had taken that API token, they would have had access to Mercedes-Benz source code. That kind of leak detection, it happens all the time, frankly. And it's an important aspect of protecting your APIs is not just looking at the traffic that you can see, but also detecting leaks outside of your infrastructure. And then we also see compromised credential detection as a key capability for API security. So if you're analyzing traffic, you should be able to detect if users are using a compromised or weak credential to authenticate. Those may be indicative of a credential stuffing attack. They may also be a legitimate user who has a compromised credential, and in that case, an opportunity for you to prevent them from prevent a future credential stuffing attack by pushing them to change their password as well. So lots of great capabilities there that we think are important on top of the core features when you're selecting an API first security tool. So with that, I do want to shift from slides to a demo. So we're gonna have Tim Ebers jump in and do a little demo of the WallArm platform.
Except for I can't. You have to unshare first.
Oh, I was sorry. Go ahead.
It's funny. They should really have a take it from the other presenter button check mark. So the first thing we're going to do here is have a little picture of what I'm going to show you. So Mulesoft, we're going to use the Mulesoft cloud. Part of the cloud, you can actually deploy Mulesoft servers in the what they call the Cloud Hub environment. And so what I've set up here is a test API. That test API is just going back to httpbin.org, which is just, if you don't know what that is, it's basically a big echo server. And I use that a lot because I want to see what I'm actually sending in, and then it sends it back. So what we're going to do is I'm going to show you how I've set these up. Our product, or our company, has a Mulesoft policy, both for the Rust-based server, as I mentioned earlier, as well as for the Java-based server. So this is actually the Java XML that we're using. What this is doing is intercepting the request. It then takes it and sends it down to the filtering node. The filtering node looks for data as well as attacks in the data. If it finds attacks, it will block it in real time. It then will send data to our cloud for our behavioral analysis or our stateful attacks, and then send it on to httpbin.org in this case, or your APIs, if it doesn't find attacks. And so this is what we're about ready to show you. And so I have this all working. I've tested it, but you know how live demos go. So we'll see how we do here. So the first thing that I want to show you is my Cloud Hub server. It is running. You can see the API that I have created here. This is the public endpoint. For those of you that are out there that want to start hitting it, there it is. Feel free to start attacking it. And then we have these deployed. Let's look at the dashboard. Here is the individual dashboards. So what we're going to do, we're going to flip over to the actual policies, but let me show you. Let's see if we can just do a refresh. Yeah. Okay, so let's show you the API manager. So what we have here is a test API that we've created. This is the same one that we saw on the other one. So here's the proxy application. This is the API. Here is the implementation URL on the back end. Here are the requests that we have been pushing through it to make sure this all worked. And then here's where it is actually running. So you've got two ways of applying the policies. You can do it at the per API level, which you can do here, or you can actually do it across all of the APIs, which is where I have it implemented. For no other reason, is it's just a habit, and I always put it here. So in this particular connector, you have a few things that you can connect or to configure. One is the WallArm node URL. I'm actually hosting this on our Secure Edge product, which is basically a WallArm hosted filtering node for our customers. So you can see that we have that set here, and then you've got node connect times, request timeouts. So you can short circuit the request. If the nodes are taking too long to respond, you can short circuit that request and then send it back onto the API. It's one of those things that is configurable, so you can configure it to whatever you'd like. And so when you put all of that together, what this looks like is a curl request to this particular endpoint, which is the domain name of our server and API out in Mulesoft land. And then what you get back is basically anything that you sent at it. So here is all of the different things that were sent to the HTTP bin from the backend. There was no JSON on it. It was a GET method. And then here are the origin IPs. And so if we take this same thing and put in a query and just put a really silly Etsy pass WD, what this will come back with as a 403 in that particular request. You will also see that there's a correlation ID in here, and you can actually take that correlation ID, go back to your logs, and see those correlation IDs right here. So you're able to actually match those up. The things that were being sent back to the customer, we actually log those in the log if you like to put them there. So now let's go look at what these look like in our product. So let's refresh this and see if we can get some sessions in here. So here is the last one that we did here, 1342. In our sessions product, you can see that we have two different requests. One was the first request that I did, and then the second one is the one that we blocked with the 403. And we can see that this attack payload was caught as a path traversal. And here's the full request of that path traversal. So we don't really change the architecture at all with Mulesoft, which is great, right? Customers hate changing their architectures. We come off kind of the side with the policy, which is really great. And you get to see all of the great things that you normally would with WallArm, including API discovery and the like.
So just to be clear, Tim, on that last point, because I think it's important, is that you can effectively deploy that WallArm connector in your Mulesoft environment without making major changes to your Mulesoft environment.
Yeah, you really make no changes to your Mulesoft environment. So as we looked at this picture, before WallArm, it looks like this. And then after WallArm, you add a little piece of policy to it. And we're basically just taking the request and then replaying that request on our filtering node. And if we block it, then it doesn't go on any further than that.
Yeah, and so the blocking occurs. The WallArm node provides the blocking functionality as well. It's not just detection; it's detection and blocking in this case.
It can, if you wanted to do that, we will absolutely block. We do have a policy that you can run asynchronously as well. Most of our customers, though, want the ability to block. Yeah. Now, even in our blocking script, you can actually turn the filtering nodes into monitoring mode, so you can start in monitoring mode and not block at all until you feel comfortable. Those all work as well.
Yeah, good. That's great. I appreciate the demo. I think that's useful. And obviously, we didn't do a demo of all of the WallArm capabilities today. We're more than happy to do one for you if that's of interest. We wanted to focus on the Mulesoft component, as part of this webinar. But WallArm provides, if we go back to the slides, all of those core capabilities that I talked about, and the set of additional capabilities that we thought were important as well. So valuable capabilities inside of WallArm. So I'm going to jump back to the slides for a moment here and share. And for these last couple of slides, just if you have questions for Tim or for myself, please feel free to put them into the comments in LinkedIn or into the Q&A in Zoom, and we'll get to those questions. If you're looking for more information about API security, GigaOM has recently published one of their radars around API security. You can get access to that from the WallArm website as well. It's just under our resources and reports, but that's there. And then I always like to make sure we talk about our next webinar. I think this next one is particularly exciting. I mentioned API Threat Stats a couple of times throughout the session. API Threat Stats is our research project. We produce a quarterly report based on real data. So this is not a survey. It's based on the attack data that we see, and then based on analysis of published API vulnerabilities and bug bounty information. Really valuable. We do it quarterly, and then we do a roll-up at the end of the year. So we just completed our roll-up from 2023, and then this is the first quarter report for API Threat Stats that's coming. We're planning to present that on May 14th, and we'd love it if you sign up for that. There's lots to learn there. So with that, let's see if we get to some questions. If there are any questions from anyone, I've got one question here for Tim, I think. Does the API discovery work with the Mulesoft policy as well?
It does. It does. We're actually capturing all the data that you would capture normally, irregardless of the fact that it comes in through Mulesoft. So everything that you would normally see, There are some caveats to those connectors, and we can talk about those. But you will see everything that you need in API discovery.
Yeah, yeah. Okay, good. And can you, this is a question from me because I just thought of it. Can you deploy other WallArm nodes, like just a regular inline node in a Mulesoft environment? Do you have to use the policy?
You can. A lot depends on who's doing what. So if MuleSoft is handling your data plane, then the answer is no, because they're using that cloudhub.io domain, and you won't have access to be able to redirect that. If you're using your own domain and happen to be using servers on-prem and doing the data plane yourself, then we absolutely could be deployed inline in a number of different ways, just like we normally would be.
Got it. Great. Okay, and then one additional question here, which I think is for me. You mentioned uh, leak data detection, but didn't talk about it any further. What is that? So I did mention in one of the slides, I talked about API leak detection and that incident with Mercedes-Benz. So it's not necessarily related to the MuleSoft deployment, but WallArm does have a capability to find leaked API data, sensitive data outside your organization. So the basic way that works is you provide us with a domain, we enumerate the subdomains, we then go look at those web properties and public Postman collections and public GitHub repositories, looking for sensitive API data that's associated with your organization. So that would mean things like a leaked token or leaked credentials or a schema that includes private endpoints that shouldn't be public. And the key, every time I explain this, the key thing to get clear there on is that we're looking at public resources. So we're not looking in your private repository. We're not doing code scanning. We're looking for sensitive data that's been leaked publicly that we can then report back to you. And then if it's the type of data that where it makes sense, you can also create a virtual patch inside of WallArm to block the use of that data. So a token is a good example of that. If you find a token that's been leaked and you want to block the use of that token, you can do that as well. And actually, the last customer I was explaining this to pointed out that this is applicable, in like a partner use case as well. So if you have a partner who's using your service and they post a token publicly, that might be something we would find and tell you about as well. So that's an explanation of what API leaks was. All right. I don't see any additional questions at this point, but if anybody has any last questions, feel free to toss them in there. And if you come up with questions after the fact, feel free to send them our way or post them in the LinkedIn comments, and we'll go back and review them as well. And if on LinkedIn, if you'd like us to follow up with you specifically, just pop the word API into a comment, and we'll pick that up and follow up with you as well. Otherwise, thanks everyone for spending the time with us. Thanks for attending. And hopefully we'll see you at the next webinar on API threat stats as well.